Welcome. In this knowledge clip, I will show you how to do a cross-variable analysis for the sample and for the population in the case where we cross an independent scale variable with an other scale variable in the dependent variable. So to do that, I will use a case of splash fun, which is an indoor swimming pool. And in the indoor swimming pool, we have a questionnaire consisting of some questions. Here are the questions. So some of the questions, you can see them here on my screen. One of the questions is, for example, what their level of satisfaction is, their satisfaction score. And another question is how many times they already visited the swimming pool. You can see both times it's an open-ended question with a numerical answer, and that indicates a scale variable. Now let's take a look at the resource question, where we will combine again a dependent and an independent variable. So this is our resource question that we will analyze right now for the sample and for the population. Is there a relation between the number of visits and the given score? If we want to analyze a resource question like that, we will indicate the two variables that we are crossing, and you can clearly see that it is indeed about the number of visits, and it is also about the score, the satisfaction score. And both these variables, they will be the dependent and the independent variable. They will both have a certain level of measurement, and depending on their level of measurement, we will do a certain type of analysis. The number of visits in this case is the independent variable. We will use this as the independent variable, and it is a scale variable because it's an open-ended question with a numerical answer. Also, the satisfaction score is a scale variable, but this is our dependent variable. We will actually ask ourselves, does their satisfaction of our customers depend on how many times they already have visited our swimming pool? So we can see here that we are crossing two times the scale variable, one as a dependent variable and one as the independent variable. That will lead us in our decision scheme, and when I open up my decision scheme here, to the last scenario here, the third box in my decision scheme, and that will give us a different type of analysis from the scenarios where we also have a nominal or an ordinal variable in one of our dependent or independent variables. So you'll see here that in the last scenario we will actually do a regression analysis consisting of a scatter plot and then the test for regression. So let's do that right now. Let's start with the sample analysis in this case. And the sample analysis is actually a scatter plot where we will scatter the dependent and the independent variable in a plot, in a chart, and then we will see if there is a relationship between them. To do that, I will put the score and the number of visits, just to make it easy for us, here somewhere in my sheet where I am actually analyzing that resource question. So let's do the scatter plot right now. I do that by inserting a scatter plot, and that's the thing with those dots here. So let's insert it, and let's insert an empty scatter plot right now. So you see it's completely empty, and I can right now click on my right mouse button to select the data. Now if I select the data, I can do that by clicking on this add button, and you see that I will first have to give it a name. So it's the relation between score and visits. That's my name. And now my X values are all the values of the independent variable, and the independent variable is the number of visits. So I select all the values under visits, and then my Y values, I remove what is here, and the Y values actually contain all the scores, all the dependent variable values. So here I select all the values of the score. And this is how you fill in that scatter plot. So if I now press on OK, you can see that you get a relation between both the dependent on the y-axis and the independent variable on the horizontal axis. Clicking a right mouse button on one of those dots allows you right now to also add a trend line. And if you add a trend line, you can actually also select an option here that you want to display the equation on the chart and also the R squared value. I like that because right now you get what we call the regression analysis. In other words, the regression model equals y equals 0.144x plus 5.1148. What does that mean? It means that your dependent variable, your y variable, which is in fact the satisfaction score, equals 0.144 multiplied by x, which is your independent variable, which is your number of visits, plus 5.1148. So this regression model consists of a constant, and that constant here, let's write this down, the constant equals 5.1148. This constant is actually the intercept. It is where your regression line, that dotted line, where it starts. You can really see that it starts at 5 point and something. So it actually means that a person that visits your swimming pool for the very first time, in other words, with a number of visits of 0 and never visited a swimming pool before, that person has already a satisfaction score of 5.1148. And then that regression model also has a slope, and that slope is positive plus 0.144. And that slope indicates, because it's positive, that every time a customer visits your swimming pool one more time, he actually or she becomes more satisfied, and that their satisfaction score increases with 0.144. So every time a customer visits a swimming pool one more time, their satisfaction score goes up with 0.144. So that's the meaning of that constant and that slope. So now we have what is called a regression model. We can model the satisfaction score of the people visiting our swimming pool. And there is a relationship between the satisfaction score and the number of times they visit our pool. It's a positive relationship. It starts at 5.1148. Customers who have never visited a swimming pool have a satisfaction score of 5.1148, and then it increases. Every time a customer visits the pool one more time, their satisfaction score goes up with 0.144. That is our sample analysis. This is what we can say for the sample. This model is true based on the people in our sample. Can we now also say that for every customer, for all our customers? Well, to know that, let's do our population analysis. So let's do the population analysis, and that will answer the question, well, can we say right now, can we apply this model that we have constructed for our sample, can we extend that to all our customers? Therefore, we need a population analysis. What type of analysis do we need for that? Well, let's go back to our decision scheme here, and you can see that we need a test for regression for that. So let's put this already here. We will need a test for regression. Again, we will find some links here below. So let's click on the first link for the test of regression, and that will guide us to the correlation test that we can do online. Yes, take me to the calculator. Okay, and here you see that we need to fill in those x values and the y values. The x values are all the values in our independent variable, so that's the number of visits. Let's select all the visit values, copy paste them here in our x value range, and do the same for our dependent variable, which are all the scores. Copy paste that also here in the y value. Yes, calculate the correlation, calculate the R. So here you see that the online calculator also constructs that scatter plot we also have in Excel, and that we get some results here. Let's snip them again, and let's take a look at what they mean. Oh, a little bit too fast. So here we have some outputs. So let's put that outputs in my Excel sheet and let's take a look what that all means. So this is the output of the online calculator. What does it tell us? Well, first of all, you see that there is a capital N of 150. So we did this test for a sample size of 150. And then we have a correlation value of 0.523. This R value, this value of correlation, you can actually look that up in a table. If you go to the slides of my course here, you can actually see that you have a table here, and in this table you have those correlations, coefficients. Those are all those R values. We have an R value here in the 1 to the third a line, which means that we actually have a moderate positive correlation between our two variables. Now, that was what we already knew, of course, because we have already constructed that correlation model for the sample. We just want to know if we can extend that to the population. So we need a p-value for that. Now the p-value is calculated based on this r-square value and on that r value. Now the r-square value is actually just the square of the r value, and you see that the squared r is 0.2735, which can actually be read as a percentage as well. So that r-square value is 27.35%. This is actually a value of determination. It actually tells you how much your model explains, or can be used to explain changes in the independent variable. Or in other words, 27.35% of the changes in your y value can be explained by changes in your x value. It tells you something about how good your model is. But we're still looking for that p-value to see if we can extend our sample conclusion to the population, if we can use this sample model, that regression model, to apply to all our customers. So therefore, we go back to our decision scheme, and you see here that you also get another link, the last link here, and if you click on that, you can actually test that R-score for the population. So let's fill here in the R-score. Where is the R-score? Let's go back to Excel. It was 0.523. So 0.523 with a capital N, a sample size of 150. Let's calculate the p-value right now for this R-score. And now we have this output here. Let's maybe snip it again. And you see here that's based on a significance level of 5%. Our p-value is really, really small. It's actually less than 0. And then 1, 2, 3, 4 zeros and a 1. So let's put it here. So we can see here that our p-value is less than 0.00001, which is really, really small. So in other words, if we draw our conclusion, we see that our p-value is in this case less than 5%, of course, because 0.00001 is actually 0.001%, so it's really, really small, definitely smaller than 5%. So in this case, we find a significant correlation, or a significant difference between our slope and the value 0. It's a significant correlation. And we can reject our null hypothesis, and it means that we actually can extend our sample model, that regression model for the sample, we can extend that to the population. So what we have set for the sample, do you remember that a customer that for the first time enters has a satisfaction score of 5.1148, and every time a customer visits our swimming pool one more time, their satisfaction score increases with 0.144. Well, we can extend that conclusion to all our customers. Or in other words, we can use that model right now to model the satisfaction score of all customers in our population. And we can actually also guess or estimate, for example, the satisfaction score of a person that visits the pool 10 times. So if we now use our model, our regression model, we can actually estimate right now the satisfaction score of a person that visited our swimming pool 10 times. And it's kind of easy because we know that the initial satisfaction score of a person that has never visited a swimming pool before is 5.1148, and then that score goes up with 0.144 times every time the customer visits the swimming pool one more time. So if we multiply that then by 10, we can actually estimate right now the satisfaction score of a person that's visited the swimming pool 10 times by using that regression model for a population. And we can do it because the correlation is significant, proven by a p-value which is less than 5%. And that is how you analyze such a research question for the sample and for the population.